Hi everybody. Here is a quick intro to what you need to know for confidence intervals for proportions, okay? For these, the key things you need to know for the conditions, right? You have to have a simple random sample. Your binomial distribution has to be satisfied. In other words, your results have to be in a yes-no style fashion. You have one or the other. There is no multiple choice style thing, okay? You also have to have your n times p and your n times q have to be at least 5. Now these are your n times p hat and q hat. These are your sample datas. Okay, your p is your sample proportion and your q is your sample proportion for getting what you don't want. Okay, as a quick reminder from way back when, your population proportion is not known. This one is going to be written in regular English, okay? This is one of the cases that break the English versus Greek rule, okay? The sample size is the number of trials, the number of times you're trying whatever it is you're trying. The X is going to be the number of successes, the number of times you have happen what you want to have happen, okay? So the number of times you get what you want, okay? The P hat with the little carrot, right? That little, the little carrot, the little hat-looking thing on top of it, dunce cap, is the sample proportion, okay? You can find that by taking your X and dividing that by N. For your values of Q, that's the probability of not getting what you want. In that case, it's 1 minus what you have for the probability of getting what you want, because your options, your choices for these particular situations are binomial. It's either you win or you lose. You get what you want or you don't get what you want. For the point estimate, the best point estimate for the population proportion for the regular P is your P hat, your sample proportion. Okay? Just like the point estimate for the mean, the best point estimate for the mean was the Greek mean. The Greek mean was the English mean. It's the sample to population. Sweet and simple. The best estimate of the population proportion is the sample proportion. Now, the formula for the margin of error, okay? For your margin of error, that's going to be written as E, just like before. That's going to be the z of alpha over 2, that's your z from the table, divided or times your square root of your P, your sample proportion for your sample, for your P and your Q. You multiply them together, and then you divide that by N, okay? For your confidence interval, you're going to take just like you did before, you're going to take the P hat, you're going to subtract the error, and add the error. And the numbers you have when you get your answer will be set off, so you've got your population, your true population will be somewhere between those two numbers. Now let's run through a quick example, all right? If I spring a 20-question pop quiz and no one in class is prepped, everybody's guessing the answers to the questions, okay? If every question has 4 options, one of which is correct, so that means you've got a 25% chance of getting the answer right. Okay, so that makes our P hat is going to be our X, is going to be not our X over N in this case, it's going to be X over our N, but what that's going to end up being is our 1 out of 4, right? Our P hat is going to give me 0.25, 25%, 1 out of 4. All right, our Q in that case is going to be the 1 minus the 25%, which is going to give us 75%, or 0.75. All right. What should I expect the population proportion to be if I want to be 90% confident? To be 90% confident, that makes our confidence level, our alpha will be 0.10 or 10%. So our z of alpha over 2 for point 10 will be 1.645 as seen on the z-table. Okay? So, what we have now is we have to look real quickly to figure out what our n is. So looking up here, it says I'm springing a 20 question pop quiz. So that means there's 20 questions. So our n is 20. I'm trying to use different colors to make it easier to see. So if we plug in our values to get our error, okay, our error is going to be our z, which is 1.645 times our square root of the p hat, which is 0.25, times our q hat, which is 0.75, and we divide that by our sample size of 20. When we do that math, we end up with 0.15927, yada 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 yada. It goes on and on and on. So I'm going to round that to 2 decimal places because that's what we've got for our table. So we've got 0.16 as our error. So when we add and subtract that to our p hat, we get 0.25 plus or minus our error of 0.16 will give us values from the range of 0.09 through 0.41. Now, if we need to estimate the sample size, what we're going to do is we're going to take, to find our n, finding the n is much easier than doing the rest of it. What you're going to do there is you're going to take your z of alpha over 2. You're going to multiply that by the p hat q hat, right? And then divide that by the error squared, okay? You can write it in this format, or you can extend the division line to go straight across and just multiply that way. So what you're doing is you're taking your z, you're squaring it, you're multiplying it by the values for your sample p and your sample q, and then you're dividing that by your error squared. Okay? If you don't know what your p is, if you're not given the sample proportion, you're going to assume a 50-50 split. All right? In other words, you're going to assume that p hat is 50% and q hat is 50%. Running through an example, if I want to test and see if students are watching the videos, how many students do I have to sample to estimate the true proportion of students watching the videos at 95% confidence with an error of 2%. Notice there was no percentage given, so I'm going to assume a 50-50 split. So I'm going to assume that p hat is 0.5 and q hat is 0.5. All right? So, and I'm just making them look a little more different because I'm trying to keep it different for you. So, the other information I'm given is the 95% confidence level. So what that means is my alpha is 5%, which alpha over 2 is 0.025, which then makes the z of alpha over 2 1.96. The next thing we have is our margin of error is 2%. So that means our E is 2%, which translates to 0.02. Okay? So to figure out our sample size, we just plug these values into our equation. So we have our N is going to equal out to our 1.96 squared times our P hat, our 0.5, times our Q hat, 0.5, divided by our error, which is 0.02 squared. So in the end, we're going to have, that's going to give us a sample size of 2401. So in order to get an accurate view, I would have to sample quite a few people.